Okay, hello everybody again. My name is Mariano Martinez Peck, and I work as a software engineer for instantiations. And now I would like to show you a couple of things which I believe Smalltalk is really good for IoT. Some of the things I will show are VA specific, and some other are completely general to Smalltalk. So this is my own personal opinion on why I believe that Smalltalk could be really good for IoT. The first thing is that it brings you all the typical benefits of being a truly object-oriented system. So in the same way that you would prefer Smalltalk over Python, Java, or whatever in any other domain, the same applies for IoT. I mean, you still have the same benefits. Smalltalk is quite easy to deploy, and that is really good for IoT because deployment, you probably need to deploy something and maybe you need to deploy on a 400 nodes or whatever because there are plenty of devices. So having an easy deployment is really important. You need to be able to debug very well because, again, you are running probably on a small board and something and you have an issue and you know how hard it is to debug those production errors or whatever. I will be showing this. Then it's also quite easy to scale and have availability because of the concept of the image. It's very easy for us to scale horizontally. We just start more images, or we can have availability. So Docker really helps with this area. I don't know any other language that could give you 40 years of experience, like is the case of Smalltalk. So I think this is something unique that I don't see any other platform. It's quite uniform, and I will show a demo at the end where I show how you can use Smalltalk for all or most of the stack on IoT, from sensoring data, applying business logic, and persisting, or like server-side and sensoring and everything. We have good FFI, at least for BA Smalltalk it's really good. We have async support. It works on ARM. And then we also have GPO accessing, so we have RAP, the C libraries for managing the GPOs. We have MQTT implementations, and all those are libraries that are usually necessary if you are doing some serious IoT. Just a small disclaimer, everything I said, I do believe about that, but I think the target, with the current status, the target of Smalltalk on embedded devices or IoT, in my opinion, it would be on a device that could be able to run Linux. Whatever it's smaller than that, it's not that easy, and Smalltalk might not be the best option, or maybe it may need some more effort. But as long as the device could run Linux, I think that Smalltalk could do a really good job. Okay, so no more slides. So we will start with the demo. Things could fail. It's really hard to demo this. So I will start first with showing a CSI web application, which is the one that we used yesterday. You see I have a server here running on port 777, and if I open a browser to localhost, I go and I see this application. It's a demo application. You click the lights, nothing fancy. Here I am running in a development environment. Okay, so I have this headful development VA Smalltalk image. And let's see, I want to deploy that. I want to deploy on whatever, server or anything. So one of the great things of VASmalltalk is to have this concept of passive image, or also known as XD, which basically allows you to bootstrap an image from scratch, and that bootstrapped passive image would live inside the development image. Then you load only what you want on that passive image, and at the end you can dump that passive image into a real isolated file, which you can then run with the VM. Okay? So in this case, I have already created one for Unix because it takes a few minutes, and I don't have that right now, but it's basically with this dialog you create an image for a given target operation system, which in this case it's Unix. I can preload some features like CSI and so on, some more settings, and apply. That will create from scratch this passive image. Here I have already created. Once you create the passive image, the next step is to load your code, load your application, whatever you want to deploy. So in this example, it's something very simple. I will go to the configuration maps, which is basically a group of applications that I want to load, and I will load this. That's it. I load this into the passive image. So now what I will do is I will now create a real final image. I will dump this passive image into a real image. So I will start a wizard, but in this case I pre-save all my preferences for this process, which is called packaging. I already pre-saved that in a class, which is this one, CSI GPO traffic light packaging instructions. So I will run this wizard with the help of this class. It's a couple of steps. In the first one, you choose which applications you want to load. So all these are the applications that were loaded on the passive image. Okay, all these on the left. And here are all the ones that I want to include in the one that I will be finally building. Okay? So I can move from left to right as many apps I want. You can see here I put all the CSI ones, and my traffic light should be somewhere like these two are my own apps and so on. Then you specify a startup class, whatever code you want to execute as startup. So when this image starts, what it will run. You can specify the file name of the image and so on. And then the process starts what is the reduction. Basically, it goes statically analyzing all the classes and methods of the apps that you said that you wanted, and it will remove all the classes that has no references, and it will remove all the methods that have no senders. So this is the reduction. Obviously, every in a while there are exceptions, like for example a package. If you use reflection, maybe there was a method that was removed, but actually it was used, but it was called with perform and the symbol, for example. So eventually you need to create your own rules for the packager, but most of the times it works out of the box. Here it shows some packager warnings, like for example you are sending this method, but I see no implementation. So there are some warnings, some are critical, some are not. So depending on what you're doing, you can trust or not. Then it can allow you to save this into a class, which is what I did for this demo. So in this case, I don't want to save it, I didn't change anything, but normally you would start with a wizard, and then you can dump all that into a class and version that with your control version system. And now it's finally dumping the image to its real file, the ICX, which is the image extension of VASmalltalk. So now I will close the wizard. I will go to, this is the directory where that development image is, and you can see if I sort by date, I have this ICX file that was just generated at 5 p.m. and 6 minutes. So we have the image ready. So what I will do now is, because this talk is about IoT, is I will deploy that into this Raspberry Pi. So here, you can see here, I have a Raspberry Pi 3, and I will move that image from my development to there. So on the left side, I have already connected with SSH, with SFTP into the Pi. So the left side of the browser is the Pi. You can see, you can see I am on the Pi, home, Pi. So I connected over SFTP, so here I am on the Pi. So inside the Pi, in this directory, I have the VASmalltalk VM, which is here. You can see basically the VM, and then on app, I have all these ICX and blah, blah, blah. So I will remove those just to start clean. Okay? And what I will do now is I will move this image, and I will call it unit stank dump. That is the startup class that I use. It will say that it already exists, so let's override. Okay, in the meanwhile, I will go back to my console. Again, here I already connected via SSH into the Pi. Okay, so what we are seeing, it's inside the Raspberry. You can see that I am Pi. So I will go to instantiations, seaside traffic light, and then I will go to app. And here you can see I have a very simple startup bash script, which is really simple. Oh, I executed. Oops. I wanted to just show it to you. So it's maybe with a, yeah, it's okay. So basically I just do a CD to this directory, I export some variables, and this is the important line which calls the VASmalltalk VM, the headless one, so that's why it's ES and X, which means ES no X. And then I specify the ICX, the image that we just built, and the ini file. So now I will run it. Okay, so now you can see here the virtual machine has already started with this image and this ini, and then as soon as it started, it will execute the code that I tell during the packaging, and that code, obviously, what it does, it just starts seaside. Okay, so if I now go to, from my machine, for example, from my Mac, I go to the Pi, which is Mariano Pi 3.local on the port 777 where seaside is listening, and I go slash traffic light. I should have the same web application, but now running on the Pi. And I build this image from Windows, so we can even have this cross-platform deployment. I will click on the green light, and that will crash. That will generate an error. This is on purpose. So let me do that. You see the server is down. If you watch in the console, it says a halt has occurred, dumping stack file CSI01, SDF, and blah, blah, blah. So we will see this in just 1 minute. What I wanted to show you before moving forward, which I briefly showed yesterday, but I don't know if everybody's was yesterday, but I really like, is the size of the virtual machine. So the one that I just used, which is the headless VM, it's 700K. This is the shared library of the headless VM compiled for ARM. The head full, it's I think it's a megabyte and a half. It's I cannot see that. Okay, yeah, it's here. It's 1 mega, 1 mega.6. This is the head full VM. I think that's it for this demo. What I wanted to show you now is some great features for debugging. So if you remember, when I click on the green, it says, okay, an error, and it dumps a file. So if we now go there, we can see this. There is this file there, this file here, CSI01 SDF, which was just generated. So what I will do now is I will copy back that file from the Pi into my machine. Okay? So I will copy it over my Windows. And now I can open a debugger. It's at the very end. I open the debugger, and the first time I saw this is, why do I need a menu to open the debugger? It was like, the debugger appears. I mean, why it makes sense to have a menu for open the debugger? Then I discovered this feature. So I would say process the add extract trace, and I will pick the file that we just generated. And here you will see a whole stack dump with all the values of the variables that trigger that error. I don't have much space. All the CSI methods, all the stack, and okay. So here it was the halt that triggered the error, and if you can see, I can see the value of the variable test. So, and I can inspect this object, and I can see the status of its instance variables. So basically, I don't have a dead string-based wallback. Instead, I have the whole serialized stack with all the states, and I am debugging. It's not actual debug because I cannot step or resume, but I can really see what happened there. So for me, I don't use the wallback anymore. I mean, the text for me are dead. With this kind of tool, it's really good. The other alternative that I wanted to show you is I will repeat the same process with the only difference that I will use a different startup class. The startup class also defines how do you handle an error if it wasn't catched before and it arrives at the very top of the Smalltalk. The startup class defines what to do with that error. So in the previous case, we used the stack dump, and now I will use one that is called ABT headless runtime startup. And here I will call it remote debug, and I will just run the same wizard. Questions so far? Cool, because I don't have time. Just kidding. Okay. And now, as soon as this finishes, I will copy again the ICX into the Pi. Okay, here it is. So I will copy, overwrite, yes. And now we will run the similar bash script with the only difference that it uses the .icx. Okay, it finished. Oh, wait, I need to do something before. Here, I need to tell that this server, this development image, will act as the host for remote debugging. So I will click here, and hopefully this will work. It's hard. Okay, since I started. Okay, now cross your fingers, and I just click on the green, and it didn't work. I choose the headless. Sorry. I thought I used the interactive. Oh, I choose the headless. Sorry. Gracias, Juani. Sorry, I picked the wrong Juli. I picked the wrong startup class. Well, but it was worth showing. That one is the default one that you use for a headless image, and what it dumps, it's a wallback. So if you cut this wallback, you see the string-based wallback that we are used to see. So that's what normally people get. And I was trying to not get that. Okay, just one sec. Okay, if it works, I want you all to yell and scream. Para. I click on the green. What? Decía headless otra vez. ¿Se me estará cambiando solo? Oh, I might have forgotten to move it into the pie. Why didn't you tell me before? Sorry guys. Okay, let's see. Okay, I don't know what is going on. Eh? Oh. Sorry, I'm not feeling very well. Well, I could have renamed it. Ahora sí. Okay, now I think it's working. Wait, wait, now. Okay, I got the debugger. sorry for the failed attempts, and thank you for your help. So you can see here, this is a truly debugger where I can get over and proceed, and I can inspect objects. Again, I can inspect this CSI component, which obviously it's a proxy because it goes over the wire via TCP/IP. I can change code, so I can come here, for example, and I can say, let's say I remove the halt because I don't want it anymore, and instead of green, I want it to be red, the green line, just to say something. So all I need to do is to save the method. Okay? I just saved the method. That's all I did. And now I can resume, and that should resume on the Pi, and the browser should follow up with my change. So I resume, and if we go back to the browser, it continued the execution with the change that I just applied. So there's no downtime between finding the error, fixing, and providing the fix. Okay, that's all about it. The next thing I wanted to show you very quickly is that not only we can run a headless VM, but instead we can also run the whole environment in the Pi. So here I am with BNC, I am connected to the Raspbian that is running on the Pi. This Linux that you are seeing here, this is Raspbian, which is running on the Pi. And I am connecting to that via BNC. Okay? So if I go here, this is a VA for ARM, and I run this, it will bring the whole development environment with everything as it would work on any other Unix. So I can, whatever, browse a big class object. And you see it's, boom, it appeared immediately in the browser. And it's a really big class, and the performance, it's usable. This is Application Manager, which is a real big widget also. So it's quite responsive, and this is even the Pi 3. With the Pi 4, it's insane. Okay, so now the next topic, briefly, it's about the GPOs, or how you access the sensors and all those things. So I guess I can kill you. So there are a few commands which are very useful for when you're doing GPO. One is Pinout. It's very helpful. It's a command that allows you to see all the pins of the Pi. So here, in this case, from the 40 header pins, I connected this external cable with this, it is called a T adapter, and allows me to, much easier to plug the cables and prototype. But normally, when you see that, that is the layout of the pins, and allows you to very easily know which pin is for what, okay? Then you can do GPO read all, which shows you all the 40 pins on the different nomenclatures, because there is BCM, wiring Pi, and then the physical number of the GPO, and then you can see also if the pin is tuning on or tuning off. So these are all command line tools, very useful. And from VASmalltalk, we obviously have a wrapper for a C library that deals with the GPOs. When you work with GPOs, there are many protocols. So if you go to the Pinout website, which is really cool, you can see all these one-wire, I2C, SPI, one-wire. All these are different protocols. Okay? So I will show you quickly. Here I have an oscillometer connected, and I will run this. It will basically, you can see the code. It will print 10 times the coordinates into the transcript. So I am running this. And now if I move it, you should be seeing all the different values that I am getting from X, Y, Z. So that's the accelerometer working. If I go to the Pi and go to Mariano Pi, GPU traffic light. Do you GPU traffic? I turn it off. So if I now go to the browser again and I enter this application now, you should see the red light, turn it on, and if I click the yellow, you should be seeing the yellow. And so this is very simple. These are simple pull-ups, pull-downs, which is the most basic example. Then I already show you the more advanced. I was going to show a temperature sensor, which is this one. So who was on my talk on Tuesday for the IoT workshop? Okay. Did you remember when I measured the temperature? Okay. So you were the lucky one that saw it for the last time because it's dead now. So sorry about that. I tried yesterday night very hard, but I literally burned it. I can't explain what I did, but yesterday I burned it, and so sorry I cannot show that. But I do have an example which I was going to use the temperature sensor, and now I will need to hack it or mock it. So this is the last example, and I am done. Here I am connecting from VASmalltalk. I installed the GemStone GVS, which is the gem builder for Smalltalk. I have loaded that GVS code into this image, and I have access to the gem builder for C, compiled for ARM. So what I just did is I have a GemStone running on the cloud, which you can see here. Okay, the internet is a little bit slow. I will go back. So I connected to that GemStone, which is somewhere on the cloud. And from here, I can do a lot of things like open a workspace on GemStone, execute code on GemStone. I can browse a class, for example, GS file, which is a GemStone class. I can browse it right from here. Again, I'm using internet at this point because I am connecting to a GemStone somewhere, and you can see all the methods and classes. I can look for implementers, all the basic tools, browse, classes, namespace, implementer, senders, workspace, and blah, blah, blah. But here you can see my server. So this is where I am connecting on this IP with this login. So this is the actual GemStone I am connecting to. And this is the example that I wanted to run. So we have this class, which is a regular subclass from object. It has a class variable called readings, and some method that just understand how to store a reading into the class variable, which is just an add on a collection. Okay? That is a normal class. Here, all I am saying with these 4 lines, it's to the gem builder, I am saying connect this class from VASmalltalk to that class on GemStone, and connect the class variable readings, which is where I am storing the readings, okay? Then I evaluate something on GemStone. I basically said clear readings, which just nils the collection, and then 3 times I just fetch the temperature, which this doesn't work. because my temperature sensor is broken. So I will just change with some hard-coded value. Okay? And then all I do is record the samples on the collection. Okay? And then I record, and then the only thing I do is to add a sample of the collection of temperatures. So I will run this. So of course it's not as fun as if I would have the real temperatures reading from the sensor, but the idea is that it's measure, wait, measure, wait, measure, wait, and then I never persist, never did anything, I just add one object into a collection. And here I have two inspectors. This is what I see on VAST, and this is what I see on GemStone. And you can see the collection was replicated. So I have automatic, transparent persistency between the Pi and a remote GemStone running on the cloud. And you can see that these are from different smalltalks because you can see the difference on, well, this is the same. But anyway, I am done with the time. You already know how to contact us. That's all.
Questions? One.
Is there any limitation on how can you...
Louder.
Is there any limitation on how can you connect the remote debugging? Many servers, many images, IP addresses?
Not that I am precisely aware of. The only thing I am aware of is that with C-side callbacks, it's sometimes it hangs, which it's some mechanic of the C-side callback. If you put it anywhere else, and we have other examples with the remote debugger, and it works quite well, but from within C-side callbacks, sometimes it hangs, which we couldn't figure out what exactly. But as connecting from many places, so far we didn't notice any issue.
Thank you.
Thank you.
So now it's